This is the third video in a series of using logarithms to solve exponential equations. This time we're going to add more than one x into the mix, and we'll show you how to isolate those x's and use logs to solve the equation. Before we start, let's take a look and do a real quick refresher here. If we had 4 to the x equals 100, again, the purpose of logarithms is to solve equations that have x as a power. So whenever you see that situation, you know logs are probably going to be needed. So what you do, you take the log of both sides, so you get the log of 4 to the x equals log 100. Use the power property of logarithms, where you have a power inside the log, you take that power and you can move it down front. So this is the same as x log 4 equals log 100, and then of course to solve for x, what we want to do is divide both sides by log 4. So x equals log 100 divided by log 4. And the only way to get that answer is to go to your calculator, and you just simply punch in log 100 divided by log 4, and you get some decimal approximately equal to 3.322. Alright, that's a real simple example. So now we're going to make them a little more complicated. So what I'm going to do is scroll down a little bit. We need some more room for this next problem, and I think I'll switch to purple for our color. Here's the problem. 3 to the x equals 4 to the x minus 2. Now the technique I'm about to show you works every time. What you do, you take the log of both sides, very similar to the simple example, and I'm going to start skipping that step. I'm just going to go ahead and apply that power rule, which says you move the power down front. I'll do that on both sides. So the left-hand side becomes x log 3, and the right-hand side becomes x minus 2, which I put in parentheses because the whole thing is the power, log 4. All right, now how do we isolate that x? Well, the first step is to, on the right-hand side, distribute the x minus 2 times the log 4. In other words, we get x log 4 minus 2 log 4. And now you want to get all your x's on one side of the equation, so I'll take this x log 4 and move it to the left. So we have x log 3 minus x log 4 equals negative 2 log 4. Keep in mind your goal is to get a single x for which you can solve. So to get that single x, we've got all the x's on the same side of the equation. Now to get the single x, we're going to factor the x out of the left-hand side. So we get x times quantity log 3 minus log 4 equals negative 2 log 4. Well, almost done actually. To isolate the x, what you want to do is take both sides of this equation and divide it by the quantity log 3 minus log 4. So on this problem, I'll just go ahead and write that in there. So we're going to divide the left-hand side by log 3 minus log 4, and we're also going to divide the right-hand side by the exact same thing, log 3 minus log 4. And I'm going to put parentheses around that to avoid confusion. Of course, on the left-hand side, log 3 minus log 4 over itself cancels, leaving our x, which we wanted. On the right-hand side, it's calculator time. You can just go straight to your calculator and type that in basically as it's written. Just be careful. The denominator needs to be in parentheses on your calculator. So you'll just type in negative 2 log 4 divided by parentheses log 3 minus log 4. Now, if you punch that in, you should get an answer approximately equal to 9.638 to the nearest thousandth. Not a real tough technique once you get it down. It's not that hard. These equations look complicated, but they're really not. Logs are our best friend when it comes to solving exponential equations. Let's take a look at another example. Let's go up just a little bit more. Get some white space here in which we can work. Similar example, we'll go 5 to the 2x power equals 9 to the x minus 1. Combining a couple steps, taking the log of both sides and pulling that power down front. So I get 2x log 5 on the left, and on the right, parentheses, x minus 1 log 9. Same technique as last time. On the right hand side, distribute the x minus 1 times the log 9, so it's x log 9 minus 1 log 9. And I don't need the 1 log 9, I'll just put minus log 9. The left-hand side stays the same for now. At this point in time, we're going to take our x's on the right and move them to the left by subtraction. So I'm going to subtract x log 9 from both sides, so I get 2x log 5, which is already on the left. Bring over x log 9 by subtraction. Leaving on the right, negative log 9. Now, just like the last problem, what you want to do is factor out the x out of both of those terms on the left-hand side. So we take x out, and that's going to leave 2 log 5 minus log 9 equals negative log 9. All right, now to get x, we'll divide both sides by the set of parentheses. So divide both sides by 2 log 5 minus log 9. Takes more time to actually do the writing than it does to solve the equation. And now it's calculator time. To evaluate that right-hand side of the equation, just type in negative log 9 divided by 2 log 5 minus log 9. And you should get approximately negative 2 151 thousandths to the nearest thousandth. So really about the same as the other. They're all about the same once you get the technique down. Let me show you one that's just a little bit different, just so you can watch out for something. All right, there's the equation. So quickly, what I could do is exactly the same thing. Let me try to speed this up. I'm going to go x log 2 equals x minus 2 log 16. Distribute on the right, x log 16 minus 2 log 16. Bring the x log 16 over to the left, so I've got x log 2 minus x log 16. Left equal to negative 2 log 16. Factor out the x. You can almost do several of these steps in your head. And if you want to, let's just do it in our head. We're going to divide both sides by log 2 minus log 16. So the final will be negative 2 log 16 divided by log 2 minus log 16. And after you punch that into your calculator, that's approximately equal to 2.66666, repeating, or if we go to the nearest thousandth, let's make that 2.667. Answer. Now, what I want to show you here is, okay, yeah, logs, the main purpose of logs is to evaluate exponential equations, and that's where you have an x as an exponent. Well, looking back at the original problem here, that's exactly what we had, but wait a minute. Don't get so caught up in thinking you have to use logs every single time, because on this problem, it would have been much easier to change bases. See, you notice on the right-hand side, 16 is a power of 2. That's 2 to the 4th. So if you just rewrite that as 2 to the 4th to the x minus 2, and now take that 4 and distribute it to the other power, because remember, a power to a power, you multiply, so that's 2 to the 4x minus 8 power. And now, since the bases are the same, you can simply set the exponents equal. X equals 4x minus 8. Subtract 4x to the left. Negative 3x equals negative 8. Divide both sides by negative 3, and you get 8/3, which is 2 2/3, or guess what? 2.667 approximately to the nearest thousandth. So don't get so caught up in logs that you lose track of your common sense. If there's an easier way to do it, take it. All right, let's do one more problem that's just a little tiny bit different. An exponential equation that involves more than just taking the log of both sides. Let's go with, how about 3 times 4 to the x over 5 equals 65. Not a real tough problem, but just to show you something to look out for. What you want to try to do in these equations is get the exponential part by itself first. So in this problem, you don't want to just go ahead and take the log of both sides immediately. If you multiply both sides by 5/3, it's going to simplify this quite a bit. So the 5/3 on the left cancels the fraction on the right, on the left, cancels the fraction on the left, so we have 4 to the x equals 325 over 3. And now we can log both sides and get x log 4 equals the log of 325/3. And to solve for x, divide both sides by log 4. Now be careful on your calculator again. Since you have that division inside the log, you want to put that in parentheses. So it's the log of parentheses 325 divided by 3, all divided by log 4. And that should come out to be approximately 3.380 if you want to try that. So solving exponential equations using logs, that's pretty much the whole story. So we'll call this video a wrap.